Welcome back, dear students. Today topic is motion in a plane. In this motion in a plane, a NEET and JEE mains as well as state common entrances they are asking the questions. Okay, so in that from vectors. Okay, so scalar and vector. What are the differences? Scalar and vectors. Okay, and how many types are there in vectors? So this all we'll discuss in this class. Okay, here scalar. Scalar quantity means what? What is scalar? Okay, scalar means the quantities which are having only magnitude. There is no direction. Only magnitude. There is no direction. So that quantities are called what? Scalars. Only magnitude but no direction. Example, a person traveled 10 meters distance. 10 meters distance traveled. Okay, which direction? Don't know. Just 10 meters distance traveled. So here magnitude is there. Okay, but direction is not there. Eastwards or westwards or northward, southward, don't know direction. So such quantities are called what? Scalar quantities. Example you can take. Okay, displacement, distance you can take. Distance you can take. Okay, and speed. Okay, and mass, temperature, etc. you can take for scalar quantities. Like that only vectors. The quantities which are having both magnitude and direction. In this case only magnitude. Okay, there is no direction. Okay, here both magnitude and direction in this. The vector quantity means, okay, the physical quantities which are having both magnitude and directions. Magnitude and directions called vector quantities. Okay, example here. Example what we can take, like displacement. Displacement you can take. Okay, velocity, force, etc. you can take. So we can observe, so having both magnitude also and direction also, particular direction. So it shows particular direction, magnitude as well as direction. So such quantities are called vector. So in addition to this, okay, it obeys the laws of vector addition. So the such quantities are called vector quantities. Okay, a vector is denoted by the symbol. The vector is denoted by the symbol. So like the arrow mark and this magnitude and arrow mark. Okay, so here this vector, for example, a body travel. Okay, so from A point to B point, A point to B point it traveled. So this AB indicates what? Magnitude, and this arrow mark indicate what? Direction. So now we can call this is AB vector. How? So this is AB vector. Here AB just indicates what? Magnitude. AB indicates magnitude. Here AB indicates what? Magnitude. Arrow mark indicates direction. The arrow mark indicate what? Direction. Therefore, this AB bar. So we can call this one bar. So the arrow mark AB above will write. So AB bar. So this is called vector. So here vector purpose we can show with simple small letters. Okay, single letter also we can show that. So here vector A. So instead of AB vector we can call vector A. So this AB bar equal to, simply we can write what? A bar we can write. Okay, A vector. Okay, simple letter also we can show that. The types of vectors, how many types are there? Okay, so what are that? The types we'll discuss now. Here first one, equal vectors. Equal vectors. Equal vectors means the two vectors which are having both magnitude and directions are same. The vectors whose magnitudes and directions are same. So that vectors are called what? Equal vectors. Okay, so we can observe magnitudes are same and directions also same. Both magnitudes and directions, the vectors whose magnitude and directions are same called equal vectors. Negative vectors means, okay, the magnitudes are same, okay, the two vectors magnitudes are same but directions are opposite. So then we'll call, so this is for example a vector means, this is b vector means how the a vector is equal to the what? Minus b vector. So negative vector. So this b vector is negative vector to the a. Both magnitudes are same but directions are opposite. So in this first case equal vector same a vector b vector. So a vector is equal to what we can take? B vector. But in this case opposite we have to take. Okay. Here polar or relative vectors. Polar or relative vectors. In these vectors direction does not change. The physical quantity, the directions does not change. So even the coordinate system in which it's defined changes but direction does not change. Okay, example, what we can take? Example here, force you can take, force you can take, and acceleration you can take, force and accelerations, okay, you can take. Next, another one, axial or pseudo vectors. Pseudo vector, the direction changes in the coordinate system if it is defined changes is called pseudo vector or what? Pseudo vector or another name is what? Axial vector. Axial vector or pseudo vector. Example, you can take angular velocity. Angular velocity you can take, or angular acceleration or angular momentum also you can take. Okay, angular momentum also you can take. Angular momentum also you can take. Okay, so these are the axial vectors, pseudo vectors. Okay, next unit vector. The unit vector means the magnitude is unity. Okay, a physical quantity, a vector whose magnitude is unity is called unit vector. Okay, here unit vector is denoted by the symbol a cap. Unit vector denoted by symbol a cap. So that formula what we can take? A bar means vector. Okay, a vector by magnitude of a bar, that is mod of a bar you can take. Unit vector denoted by symbol a cap, that equal to a bar by mod of a bar. Next, null vector. Null vector means whose magnitude is 0. Magnitude is 0. So this direction is indeterminate. There is no initial point and final points, both are same. Direction is indeterminate. Okay, so that is called null vector or zero vector. Another name also there, zero vector. The last, position vector. Position of a particle described by a vector. Position vector, okay, in a coordinate system, here in xyz plane at origin, okay, in xyz plane a particle p particle is there at r distance. So that time we can write, okay, so this position vector we can write op bar is equal to xi bar plus yj bar plus zk bar we can write. This magnitude, how to write? Mod of op bar or simply, okay, r bar, okay, mod of op bar or simply mod r bar is equal to, so we can write under root, okay, x square plus y square plus z square. X square plus y square plus z square we can write. Okay, next topic, directional cosines. So what are directional cosines? Okay, they'll give one equation vector form, they'll ask the directional cosines to find the directional cosines, or sometimes directional cosines they'll give, so write the vector form they'll ask. So what are directional cosines? So you can observe here a vector a bar is making, okay, so angle with the x-axis is what, alpha, with y-axis is beta, and z-axis is what, gamma you can take. Okay, so here the cosines of the angles in this magnitude is what, okay, the just now we discussed in the magnitude of this vector is what, mod of a bar equal to what we can write, ax I bar. Okay, x-axis component I'm saying ax, okay, ax I bar plus like that only y-axis ay j bar, and z-axis is what, az k bar. Okay, here directional cosines I'm taking L, M, and directional cosines I'm taking. Okay, here cos alpha, the cos alpha equal to what I am taking, the x component, what magnitude is what, ax, but total magnitude is what, mod of a bar. So this cos alpha, okay, ax by mod of a bar, like that only cos beta equal to ay by, cos beta equal to what we can take, y-axis angle is how much, beta, ay by, okay, so y-axis component I am taking ay, so that is ay by mod of a bar we can take. So like that only cos gamma is what, az, z-axis, okay, so z-axis I am taking az, okay, so az by mod of a bar I am taking. Okay, these cos alpha, cos beta, cos gamma are called directional cosines. Okay, here relation between the cos alpha, cos beta, cos gamma, observe here, cos square alpha plus cos square beta plus cos square gamma equal to 1. So this is a directional cosine, the main formula. The sum of cos square alpha plus cos square beta plus cos square gamma equal to what, 1. So like that only sin square alpha plus sin square beta plus sin square gamma is equal to what, 2. Sin square alpha plus sin square beta plus sin square gamma equal to what, 2. Here if, okay, in directional cosines they'll ask like this, if, okay, in this cos alpha equal to, okay, if cos alpha equal to L and cos gamma equal to, cos beta equal to M, cos gamma equal to N, therefore the relation is what they'll ask. Okay, here cos square alpha plus cos square beta plus cos square gamma equal to what, 1. So the relation between cos square alpha, cos square beta, cos square gamma equal to what, 1. So like this directional cosines, okay, formulas they'll ask. Okay, in this, based on these problems, how they'll ask problems, so now I'll discuss the problem. So one question is given, okay, one question is given in this, so you can check on the screen. Okay, if P bar equal to I bar plus 2j bar plus 6k bar, I bar plus 2j bar plus 6k bar, P bar equal to what the given, I bar plus 2j bar plus 6k bar. One question is given, so what they are asking in this, find the directional cosines, find the directional cosines. The first point is what, to measure the directional cosines. First point is what, find the magnitude of that vector. Magnitude is what, mod of P bar, that is nothing but P, that equal to under root, here I component what is there, just 1 is there, 1 square, plus j component what is it, 2 is 2 square, plus k component is what, 6 whole square. Okay, so that equal to under root 1 plus 4 plus 36, that is root 41. So your mod of P bar, okay, mod of P bar or simply P, how much we got, so 30, how much we got, root 41 we got. Now you find the directional cosines, cos alpha, cos beta, cos gamma. Cos alpha formula just now we discussed ax by mod of a bar. Okay, ax by mod of a bar. So that meaning is what? Ax. How much ax? I component magnitude is how much? 1 by root 41. Root 41. So like that only cos beta. Cos beta equal to what? Ay by mod of a bar. Ay is how much is there? Number 2. The 2 by root 41. So like that only cos gamma. Cos gamma is how much? Cos gamma equal to az by mod of a bar, that equal to az how much is there? 6. 6 by root 41. So therefore we can say that the directional cosines are, what are the directional cosines? First cos alpha. Okay, cos alpha how much we got? Cos alpha 1 by root 41, comma cos beta how much we got? 2 by root 41, and cos gamma how much? 6 by root 41. So these are the directional cosines of the given vector form. Okay, so which option is correct? Okay, here which option is correct? The second option is correct answer. Another form, okay, directional cosines they only give. Okay, now we have to find the equation. So we can observe in the question. Okay, what they given? The directional cosines of a vector a bar are cos alpha equal to 4 by 5 root 2. Okay, so next cos beta equal to, cos beta is given, okay, 1 by root 2, and cos gamma equal to 3 by 5 root 2. Directional cosines they only given, then the vector of a bar is how much they are asking. Okay, so that the vector form we know that what is the vector form. So a bar equal to axi bar plus a by j bar. Vector form is what? Okay, vector a bar equal to axi bar plus a by j bar plus az k bar. So in this form we have to bring this directional cosines. Okay, observe here cos alpha is there, 4 by 5 root 2 is there, cos beta just 1 by root is there, cos gamma 3 by 5 root 2. So we understood the magnitude should be, the resultant vector magnitude should be same for all directional cosines. But here 5 root 2 is there, here root 2 is there, again here 5 root 2 is there. Okay, so what I am doing here, with 5 I am multiplying and dividing with 5. Okay, with 5 divided, then I multiplied. Okay, equation does not change. Now the magnitudes are same. So now directional cosine formula we know that. What is the formula? Cos alpha equal to ax by mod of a bar. So here instead of ax what is there? Okay, therefore ax what is there here? From here 4 is there. Okay, so like that only cos beta equal to ay by mod of a bar. Instead of ay what is there? 5 is there. Ay equal to what? 5. And in cos gamma az by mod of a bar, that means az equal to what? 3. Now you can write the equation. What is the equation? A bar equal to ax I bar. Ax is what? 4. 4 I bar plus ay is what? Okay, ay how much we got? 5. 5 j bar plus az is how much? 3. 3k bar. So this is the a bar. Okay, equal to 4 I bar plus 5 j bar plus 3k bar. Which option is correct? So we can check here 4 I bar plus 5 j bar plus 3k bar. The second option is correct answer. In another, a vector is given 2i bar minus 3j bar plus 4k bar. A vector is given 2i bar minus 3j bar plus 4k bar. Okay, so the vector is given like that. Okay, what they are asking, in these components yz plane and zx plane, yz plane and zx plane respectively, yz and ZX planes they are asking, YZ plane and ZX plane they are asking. Here observe here YZ. So this is AX, this is AY, AZ. YZ plane they are asking, this is Y component, this is Z component. So therefore components, how to find magnitude of the components under root. So this component Y component is what? Minus 3. Minus 3 whole square plus 4 square is equal to 3 square is what? 9 and 4 square is 16 under root 25, that equal to how much? 5. So here YZ component we got 5 units and we'll see ZX similar, ZX whole square equal to, okay, under root ZX plane equal to, this is Z axis component, this is X axis component. So ZX plane they are asking, so Z component is 4 square and X component is what? 2 square. Here 4 square is 16 and 2 square is what? 4. How much? Root 20. Root 20 here options. Okay, what we can give? Options. Okay, 2 root 5 is given. Root 20 not there. So we can write this one 4 5 ja. 4 into 5 ja. Root 4 is what? 2 root 5. Therefore, what are the planes? YZ plane is 5 units and ZX plane is what? 2 root 5 units. So which option is correct? Second option is correct. In another time, so the angle with the axis they lost. A vector making angle with the x-axis. So at what angle? So that vector is there, the magnitude of the vector is there. So they'll ask the questions. Okay, so we'll see. One question is given. So angle made by the vector root 3 I bar plus j bar. Root 3 I bar plus j bar. Okay, root 3 I bar plus j bar with the x-axis is, with the x-axis is asking, x-axis is asking. Okay, here we can observe. Okay, so this x-axis, with the x-axis they are asking, so we can observe. So this vector I am taking like a bar vector I am taking, so the vector name I am taking a bar. Okay, so here I am making one, I am drawing one graph, x-axis, y-axis. So we know that x-axis I vector form and y-axis j vector. This is the origin. The resultant vector, that is nothing but what? A bar, a bar. So they are saying angle with the x-axis, they are saying angle with the x-axis, okay, theta will take, theta will take. So this angle how much for this vector root 3 I bar plus j bar? Root 3 I bar means this magnitude is how much? Ax is how much? This Ax value is what? Root 3 and this Ay value is how much? Nothing means what? 1. So then the angle with the x-axis how much they are asking. So what, how to do this one? We'll see. With y-axis one parallel I am taking, one parallel line I am taking. So here j component, that ay is 1 means, and okay, this one also the parallel line. So here also same only this vector if you take c. Okay, so what happened? So this vector with the x-axis, okay, this one also what? 1 only. Magnitude is how much? 1 only. Already ax is there root 3. So now apply the tan function. Tan theta equal to opposite by adjacent. Tan theta equal to opposite side is how much? 1 is there. Adjacent is what? Root 3 is there. Tan theta equal to 1 by root 3. Tan theta equal to 1 by root 3 means in tan function. So in tan table when we will get for 30 degrees. Okay, for 30 degrees. Okay, 30 degrees purpose we will get tan 30 degrees. Tan I am cancelling. Therefore theta equal to what? 30 degrees. But in option in radians they given. Okay, Therefore, theta equal to 30 degrees means how much? Pi by 6. 30 means how much? Pi by 6. So like this we have to calculate the answers. Which option is correct? The first option is correct. Next, another type, theory type, the last questions like this. Okay, you can check. A person runs along a circular path of radius 5 meters. If it completes half of the circle, find the magnitude of the displacement vector, how far the person ran. Okay, here a person ran along the circular path. Okay, the circular path radius is how much? The circular path radius, the given radius value given 5 meters. 5 meters. Okay, this is a center. Okay, the person completes half of the circle they are saying. So started from A point. Okay, he covers half of the circle. Okay, and reached B point. So A point to the person reached B point. Then they are asking displacement vector and how far he ran. Okay, how to find? So observe here, displacement vector. Displacement means the shortest path between initial and final points. The initial point is A, starting point. Final point is what? B. So A point to B point. A point to B point. Here radius is given 5 meters. Okay, O to A 5 meters means O to B also what? 5 meters only, no? 5 meters only. So displacement here, what we can take? Displacement shortest path. So OA plus AB, OA plus AB we can take. Okay, OA plus, okay, OB. Here 5 meters plus 5 meters, total how much? 10 meters. Okay, the displacement is how much? 10 meters. Okay, now they are asking, okay, how far, okay, he ran. So actual path is what? Half of the circle is covered, actual path. So this is nothing but half of the circle covered. So we know that total circumference of the circle, we know that how much? Circumference of the circle how much? 2 pi r. Here half circle only covered. Half circle means shall I take pi r? Pi r. So here pi into r value they given. How much? Radius how much given? 5 meters. So therefore how much? 5 pi. So the displacement is 10 meters and actual covered path distance is how much? 5 pi. If you understand this concept, please like the video and share to your friends. It will be helpful to your friends. Okay, and don't forget to subscribe. Okay, so thank you. Part 2 will be there, motion in a plane. Okay, in the topic we'll discuss next parallelogram law vectors and projectile topics are there most important. So in the part 2 we'll discuss. Thank you.